Security is second lecture. In this lecture, we're gonna discuss how can we blockchain technology will be provide or make secure our autonomous vehicle and communications also automotive technologies. So as we know that nowadays blockchain technology is very emerging technology that can be make it secure, distributed, trusted network for the communications and for the different applications. The blockchain is started from the cryptocurrencies, like from the currencies we'll be using in the worldwide, and it's gonna be provide that secure currencies information, currencies exchange things. But later on, the researchers found that blockchain can be used in different application also, in IoT, in smart cities, in different educations, agriculture, so many things. So in here we are discussing about our blockchain technology, how can be used in autonomous vehicle. So first of all, that we can introduce about what is the blockchain technology. As we know that blockchain technology is distributed ledger technology comprised of unchangeable digitally recorded data in packages that call the blocks, right? So it has a mainly four features: shared ledger, cryptography, shared contract, and consensus. So in shared ledger will be used append only system of record with the shared across the business network. Cryptography will be provided ensuring secure and authenticated and verifiable transactions. Transaction means communications or data exchange things. And shared contract, it is the business terms embedded in the transaction database that is executed with the transactions. And last, so consensus, that is the most important features of this blockchain technology, that is the all parties agree to network verified transaction. That means who is involved in the network, like what vehicles gonna be connected with other vehicles, they must be agreed, they must be verified by the other network members. They cannot only one-to-one communication. They have everyone gonna be verified. This communication gonna be between the legal entities. Then it consensus will make it that consensus will be help for the verifying the transaction. So that how to blockchain technologies is provide a security perspective in their features. Shared ledger, it will provide the availability, retainability, and traceability. With the shared ledger, that means we have like every network member of the network, they have same information about what transactions is happened within a network, what the communication and what type of data is sharing within a network. Those information will be stored in the everyone as a set in their own system. That called the ledger. Second one, cryptography. They provide that cryptography provide that confidentiality, data encryption, integrity, no modification. That cryptography will be provided actually who is involved in the network. They have own hash ID. They have their data is communicating with those hash IDs. So they don't know who is the real member of that person, who is that make that privacy more secure and confidence that, and they verifying with the help of this cryptographic algorithms. Third one is the digital signature. This provide that trust, the negotiation process and final contract, trustability, non-repudiation. This means that with the digital signature, before the involving in the network, member must be the sign their digital signature. So they can be make it trustable. Only trustable person can be communicate within the network. And consensus, they provide also trustability, liability, authentication, and authorization. So that consensus is make that who is the making the consent, who is the involving the network, who is providing that verification of transaction, that this network members are the liable, and they have some specific authentication authorization rights, then they can do it with the verification, make the concession. So these are some blockchain technology security solutions who's already working on the autonomous vehicles or in automotive vehicle technologies. So these are the blockchain based intelligent vehicle features. Like features has the shared driving, ride sharing, transaction, fuel, toll, insurance, money transactions like things, store vehicle usage information, decentralized transportation, secure vehicle communications, privacy, and autonomous self-driving vehicle and trusted vehicle communication environment. So these are the some organizations who are working in the which specific fields is explaining in this slide. For example, this is the Institute of Autonomous Automation, Chinese Academy. It works for the decentralized transportation field. University New South Wales is working on the secure vehicular communication and privacy and also autonomous vehicle. Same as the University of California is working for the shared driving, secure communication, self-driving and privacy field. So these are some organizations. For example, like MIT, it is working for the transaction fuel and toll transaction, money transactions things, vehicular communication in vehicular network. And these are some other organizations who are working for this particular field. So here is the blockchain overview of the blockchain technology in autonomous communication, autonomous vehicle communication. For example, you can see V2X, V2V, V2 infrastructure communications is gonna be happened. For the example, like these vehicles, all vehicles will be connected through the blockchain technology. When they are doing the communications, so they will doing within the blockchain network. So these are the overview concept of the autonomous vehicle communication. So this is the process of the blockchain technology process. How can it will work within a network, within a vehicles. For example, this is the sender. He want to create transaction senders and it make the block and it using the crypto hash ID. Then using the transaction is distributed and validated via the cryptography. When he sends some information in the network, for example, this is the network blockchain servers, and everyone has a distributed data. Everyone has their own information. So everyone has the same information between them, and these are the receivers. So once they verify these data, blockchain servers or blockchain network member, they verify the transaction, sender's transaction, then receiver gonna be received. So sender creates the transaction is distributed and validated by the cryptographic hashing, that is the crypto hashing, and transaction is committed to the blockchain and miners are rewarded. Miners are those members who are verifying first. For example, when sender sends some transaction, with the transaction there is going to some critical mathematical problem with them, and these are members are trying to solve those problems, and who solved first, and then after solution and he verifying the sender, that member is called the miner, and these are the get the some reward, and then receiver receive the transaction of this network. So this is the complete process of the blockchain technology in autonomous vehicle network. So autonomous blockchain for autonomous vehicle security solutions, we have this layer, network layer. We are using the application layer, will be connected. Application, transport and network layer, they are all connected with the blockchain adoption layer. There is a header format. In the header format, they have a previous information, cryptography, that hash ID, that consensus, they have a solving with the network, consensus, and the digital signature. These all four features will be included in the blockchain layer, that in header format. And then it will be secure, that MAC layer and physical layer gonna be secure with the security public key infrastructure, PKI, and then cognitive layers, cognitive MAC information, message authentication code. So these were the adoptions layer. Header format will be added with the app. That previous information, this whole block gonna be connected with the transport and routing plan, how to send the information, which way we send the information fastly, and it will be providing the network, that vehicles connected with the Wi-Fi, connected with the cellular network, connected with the satellite, whatever we are using. That means in a communication will be used V2V communication, V2 human to vehicle to person communication, vehicle to infrastructure communication, they will use this framework for the autonomous vehicle security. So here blockchain technology for autonomous vehicles, it will use blockchain, that's called block, will be secure trusted communication based on the blockchain server. Store the vehicle hash ID, IVTP, that is the intelligent vehicle trust point, and communication details will be stored in the ledger in the block, and then they have a proof of driving, ledger, smart contract, and hash. For example, they will using, for example, in here these are the connected vehicles each other, and they are communicating each other. All information gonna be stored in the blocks. So that is the blockchain server for the IVTP. IVTP is, as I mentioned, that the intelligent vehicle trust fund, that is the crypto ID for giving by the using for the reward purpose in the network. We'll explain later. So this is the overview, complete blockchain technology using in the autonomous vehicle server. How can it works? It's gonna be explained here in this diagram. For example, this IV, that is the intelligent vehicle, autonomous vehicle, IV1, IV2, they are communicating each other, V2V communication. They have vehicles ID, IV1, and they have transaction ID that will be using for the crypto ID. And when they both are stored same information in their database, that is the blockchain server, you can see, and they have this IVTP gonna be organized or issued by the authorized organization of the IVTP, that is center to issue the unique crypto ID for the vehicles, and person user to buy the crypto unique ID from them. From only they can be accessed from here. Once they access, they will need to gain. Only one time they can be buy that crypto ID, that IVTP. And then the communication is regular cloud, vehicle to everything communications. They have main blockchain server. They are all connected to each other with this server. So, and this server has stored all information of these IV1, IV2, every vehicles. So here, that is methodology. For example, laser has this all informations about the vehicles communication. Hash ID will be works like block generation will gonna be generate like this. And in this we have proposed that proof of driving. Proof of driving means they will provide for the consensus thing. Proof of driving algorithm. That algorithm will be used. That vehicle who is the communicating, who is the doing the transactions, who is the transmitting the message, anything, he must be the in the network. He is not like hacker will be somewhere standing and he just try to send some bogus messages and attacking the network. So this algorithm is provide that proof ID. In this we can see that function proof of ID will be connected with the nonce and difficulties. Nonce, we know that predefined random numbers, and then difficulties means how much it gonna be used. What the we not gonna be like for the vehicle in case we need to like in our blockchain in cryptocurrency we need to take a transactions process in a time. So we don't need the immediately information, but in the vehicle during the vehicle communication we must be the our informations. We need to do the verification. We need to verification is immediately. We cannot wait for the long time. So for that we use the difficulty. They can be make that lightweight verification process for our consensus process, and then result is given the original proof of driving nonce difficulty. Then we added the original proof of driving is success if result is valid, and return blockchain station with the nonce difficulty and the null process. And then we have the another this smart contract. That smart contract make that before joining the network of the our blockchain server, we must be the agree on the terms and conditions. For example, like we are using the like we going to some shop. We not shop that we can use the can. We going to buy something. some mall. So if there is a fixed price, if we are agree those price, then we can buy. If not agree, we cannot buy. Same that is conditions like here. If there is a predefined some rules regulation, who will be agree in this rule regulation, he can be signed the own contract and he can join the network. That is the smart contract works for that purpose. And then ledger, as we know that ledger will be stored all informations and these functions of the what transaction will happen between the network, it will be stored in the ledger. So this is the block structure, how to block gonna be generate. The block is like this is the previous information, is the current block ID. Then it is the previous information. It has a timestamp and version of the block creation version. Then nonce and target means where it gonna be send the information. And then later on it will use the message. What message is wanna broadcast in the network. So we can see that the block n-1 has another block when block n, it has also previous information. Previous one means if someone is find out that who is the sending what message in the last time what message is there, it can be used tracked by their previous block hash ID. But they cannot find it their personal information. They can find it the only hash ID. And then it is the same. These are the blocks structure. Then here we can see that previous block has with the timestamp, version, nonce, hash Merkle root will be connect with the hash function. Hash value number of the fixed length is 256 bit. But in this case, we can be reduced. That we cannot use the 256 multiplied by 256. For the cryptocurrency case, it will be using the 256 to the power 256 bits. So it has a very huge cryptocurrency ID. But in vehicle case, we cannot create that long ID, hash ID. So we need to find out that short way. There it's gonna be calculate our calculation power is gonna be reduced. That's things. So here we discuss about the IVTP. IVTP is the intelligent trust point, and that is the access method. It is the crypto similar as the cryptocurrencies is the crypto ID that gonna be assigned by the vehicles, and vehicles they will use for this IVTP as a trust point, as a when some vehicle is verifying someone, he will give as a reward. So in our cases, we cannot use the currency as a reward. We are gonna use some crypto number, crypto ID as a reward. So as much as which any vehicle has the highest crypto ID, highest IVTP, that vehicle will be the more trustable vehicles in the network. So if in the later on they have lot of vehicles in IVTP, so they will get some preferences like their message is the trustable, and they will get it some highest point for the verifications for in the network. And they have like when they gonna be sell their vehicle, so they will resell their vehicle, so they will see buyer can be see the only this trusted point. If have a highest trust one, that means vehicle is the most trustable. They have no any bad any bad information. He never did that things. Those type of things is gonna be verified by the IVTP. So now, but in this case, as much as like vehicle network sometimes has a lot of vehicle in the same time, in the same places. So there is a lot of conjunction is gonna be happen. So for this, we had using the branching of the blockchain algorithm for the vehicles. So what does it mean branching? Branching means when we using some particular fixed size of the blockchain server, there our data gonna be upload and it gonna be rewrite after the finishing the size. And there is only they will use only the some unusual events informations for the main server. So in here we have two blockchain blockchain server, there is the one is local LDB, local database. Another one is the main database, main DB. So in the main DB, it will be using only some unusual events happened in the network, like some accident has happened, someone is sending wrong messages, some is sending bogus information, and some hackers is trying to, they only try to only store those information in here, and that information gonna be stored from the long time, means maybe lifelong, maybe it's depend on the network to network. And local DB, it gonna be used only between the one region, particular region, and that region has a current time what information is going on in the network. They are just updating those local DB, and it's gonna be upgrade, and it's gonna be rewrite after once the size once the data is size of the server is gonna be full. So in here it will use the broadcaster to other vehicle to vehicle communication, where message broadcast to other vehicles, unicast to another vehicles, the message unicast to specific vehicles, unicast to LDB, that is message broadcast to LDB, that is a local database, a vehicle to the infrastructure, and unicast to the MV, main database, main blockchain, the message unicast for the main blockchain, a vehicle to the infrastructure. So these algorithms we use for our reducing the congestion and making the fast process, fast calculation of the regular communication. Flowchart of our proposed system, branch-based technology. You can see the ITS blockchain module. It has 3 threads. First one, incoming packet handler. They're gonna be handle the whole packet information. Second, miner. Third, main thread. Packet handler will be used to check the pipe for the incoming packets and replay or relay to the other threads for the processing section, and this process is gonna be repeatable as in LDB. Second is the miner. Miner will receive the state change notification, and it will generate the proof of work. There is mining and send the proof of work for the verification for the consensus, and if consensus is the made, then update the IBTP received for the mining thing, and then again it change going for the changing to state change process. Third one is the main thread. It's gonna be informed to others node who is doing the process. In the same time with this, they will get the information. Okay, you don't need to do anything, just change your state. So they will change mining state to another in the normal state, and they will store all information. And then it has the how to change the block. The block has a block data, previous has block 2 and block 1 information. Then it will be connect with this information. How to change the block branching. The block, it will be when full, it's gonna be divided in the another part, then in the another part, then it's gonna be merged later on. And this block is block branches cannot merge. It will be merged unless the latest local DB, LDB, data blockchain, local DB label is fully filled. Once the fully filled, then it's gonna be merged. If not not filled, the local data blockchain server, then it will be again gonna be included inside of the block, that local LDB. So this is the pseudocode for the miner thread. We use the function miner thread, that is star. If while that is the true, it cannot be accessed for the mining is the true. Then if to mine is empty, then it continue. Else the template, get the template, mine the block, mine block to mine template, and then add the new blocks in their own blockchain, then their chain. And if mining is clear, then after finishing adding the blocks, it will be miner gonna be clear in their database. So for example, initial, the branching factor is the 0. This means that is the number of branch is the 1. Whenever the new block is added, local data blockchain calculate the average time taken by the state change, how much is the time to change, state change included in the block. To get the verify, that is for a new block B with an state change. These are the algorithms method for the numerical analysis. How to do that? It will use the thread, delta thread is average equal to sigma m I equal to 1 is the initiation, I is the initiating process, is the one block, then T block minus the Ti the broadcasting, and they all divided by the number of total state change. This is the process for the how to change their state of the blocks. So if this value is greater than some verifying and threshold, example 5s state, the value of branching factor is increased by the 1. Number of branches become the twice the earlier number of branches. So that is the example for the block of branching algorithm, how to do the branching algorithm. Then it is the unbranching algorithm. Once like how to can be like once time is the data is going to be stored and then the congestion is the reduced, then we don't need to that branches. So we need to reduce that branches, unbranching those server. For that it will use whenever a new block is added that fills up the latest level in the local database, the average time taken, that is the delta T average, delta thread average by the state changes include in the blocks of that level is the calculated. And then if delta T average is less than delta T threshold, the branching factor is decreased by 1. And if the simulation generated random velocities, then we could also give the random starting position to the vehicles, which enable us to test the various scenarios. So this is the algorithm for the unbranching our blockchain, the local blockchain server. So this is the block mining for the vehicles. The main mining block, it will use the function pseudocode for the mining blocks. We use the function mining block to mine and template, and then create the skeleton of the block using the obtain the template. Template means we need to find out that previous hash ID and what's the size in the block has what type of information gonna be stored. We need to predefine, we need to provide that template. So create a skeleton for the block using the obtain template. While block size is less than maximum size, then add the next state change to the block. Else insert the non into the block. Nonce is the random numbers. We can predefine the difficulties. Then we need to generate the proof of work. For the proof of work, while SH256 block, SH algorithm, hash algorithm, secure hash algorithm, 256 bit block does not begin with the difficulty number of zeros, then replace nonce with the another nonce. At this juncture, the block has been mined, block has been mined, and then it will return to the make the blocks. That is earned, it complete the whole mining process. Now second, we use the simulation scenario. We use the intersection scenario to prove our proposed system, our creating block and generating the whole blockchain system. We use that intersection scenario. For this function, simulate intersection and start while not get the transaction equity. Then it will be new transaction equals to get the transaction front. If new transaction protocol is equal to the start vehicle, who is the starting that transaction is equal to the start vehicle, then it's moving to add the new transaction with the vehicle ID. And then else, if new block transaction is equal to the reach intersection, then it's moving dot remove the new block vehicle ID. At the intersection, add new transaction vehicle ID, new transaction timestamp. Time is and sort the at the intersection, sorting according to the timestamp. So If vehicle is present at the intersection is equal to false, then moving at intersection in the front, that value will gonna be 0. And then at the intersection dot remove is the front side is empty. That is the whole process for the intersections, our use case for the intersection. For example, this is the simulation use case we are discussing, like vehicles all coming from this intersection, IV1, IV2, IV3 and 4, this intersection, and then it will be broadcasting their message from the with the timestamp, their IVTP, their IVA address, crypto address with the timestamp, and their message broadcasting that I am coming on this intersection. So here they are, every vehicle is broadcasting that information. So this is the blockchain based use case scenario we use for our simulation work to explain verifying our blockchain idea for the autonomous vehicle. So for this simulation, we using the automotive intersection use case scenario based on low latency specification. We use the 5 system, our 1 as a blockchain server and 4 PCs as the intersections, vehicles intersections, self-driving vehicles. So these are the process use case scenario. Here we can see these scenarios will be explaining here. So each vehicle, for example, IV1 vehicle, intelligent vehicle, first vehicle, it comes 10:06 a.m. in the network, and it broadcasting this information to timestamp, processing time 0 to 0.5 milliseconds. Then it will be sent 10, 10, 10. These are the value of IVTP, how much value is in the each IVTP. There is a no vehicle issued, start the block. There is a no problem because it's just first broadcaster of the message, then is no problem. Then IV1, IV2 send the start block. Sorry, it comes 10 to 06 minute, and it is 000 time. It has no vehicle issued. 05, it get the information from the receive the information message from the IV1. Vehicle 2 sends the start block, start moving, and vehicle 3 will comes to 06 millisecond, and IV3 and IV4 send the start block, start moving. Then IV2 will be due, that is the arrival time 10 to, it will be start IV1, send the start blocks, starts moving, that is the 07 is gonna be start, and then 01, 010, it will be IV2 reaches the intersection and IV1 mines the block, IV2 crosses the intersection after the consensus. Then IV3 is reaches 10:04 and it will be broadcast the IV2 reaches the intersection and IV1 mines the block, IV2 crosses the intersection after the consensus, and IV4 reaches the intersection, issue the intersection block, and IV1 mines it but cannot move since IV2 is crossing. Then 15 milliseconds it will be use the IV4 which came second is now able to cross, IV3 which came in third is now able to cross, move, IV1 mined this block, and IV1 which came in last is now able to cross. So this all process is happened with the based on this timestamp. So they will calculating, each vehicle is gonna be calculated there which vehicle get the receive the information message from first. So here we using for the difficulty level of the proof of work, we use that level 1, that is 0 millisecond. It will access this process to 0.00045 milliseconds. Level 2, there you will be using the 2 nonce, there is a 0.067. Level 3 nonce will be using the 1.0383. Level 4 will be using the 11.9, and level 5 will be used the 62.99 millisecond for the processing, further doing the consensus proof of work processing. Now we find that our result is showing average time for the state change validation with the load of 2200 seconds per minute. Sorry, 2200 state changes per minute, and if the difficulty is too high, the block size become too large to handle, as the rate of state change production is also high. In here we can see these are the highest one, we using the difficulties level 5, and then if difficulty is too low, mining overhead rises and reducing the throughput. This last one, this is the lowest difficulty we using for the only 0. So second, in here we change the average time of state change validation for load, how much time it will take the load of 2400 state change per minute. For load of 2400 state change per minute, we see that average time of state change validation has decreased simply from around 15 seconds for the unbranched local database, local blockchain, then to around the 6.5 seconds for LDB with the 1 branch, and 5.5 seconds for LDB with the 4 branches. So this is proof that branching indeed helps the speeding up the consensus process. Then again, it's using for the average time for the state change validation with a load of 32 state change per minute, 3200. For this, for load of 3200 state changes per minute, the average time for state change validation is decreased from, this one we can see is the decreased from around 23 seconds, and unbranched local blockchain to around 16 seconds for LDB with the 1 branch, and 14 seconds for LDB with the 4 branches. However, branching comes with the drawback of high amount of duplicate state changes lost in the blocks. This is the also drawback of our branching mechanism. Branching idea, their average duplicate state change per block with a load of 2200. For load of 2200 state change per minute, the amount of duplicate state changes per block in unbranched local blockchain is less than 1. However, with the 2 branches, with this increasing the around 17 per block, and with 4 branches 25 per block, can find out these issues in here. 1 branch, 2 branches, 4 branches. 1 branch is we can get it easily, but 2 branches and 4 branches is making the more duplication. So in here we say that what type of current scenario we can differentiate, compare with our idea and proposed idea and the existing current time scenario. In current time scenario is like traffic is working like this. It has some issue for this accident. They are not following some rules and regulations, so they can happen the accident in the traffic, in the intersection. But if we using the blockchain server, if we are using the blockchain network, so there is the communicating seamless networking. Everyone has their information, they are stored, they are providing the messaging, broadcasting, they are coming to in network, and they will work well. And every blockchain server will be stored the whole vehicle ID and their transaction information in the network, in the blockchain server. These are the local blockchain server, and these all information, only usual information, unusual information gonna be stored in the main blockchain server. So finally, we gonna conclude this our talk, this lecture, the automotive cybersecurity perspective to understand the problem and need of the domain of automotive technologies. The automotive cybersecurity big challenges is manufacturing during the instant, like in vehicle side we using a lot of sensors, but we need to provide that. We need to start the security from the designing phases when we design any vehicles inside of the vehicles phases. And then communication V2V, V2Y, and V2C, V2P. Every communication has this type of issue. And automotive cybersecurity, these are some organizations who are working very hard. SAE, Tesla, Google, for providing the cybersecurity, solving the cybersecurity issue. So our proposed idea, automotive blockchain technology, it builds the trust. Distributed and decentralized data will be sharing within a network and maintain the privacy of each vehicle, and all information is information transmission in the network. That is the more reliable. That is the our proposed idea will be provided.